As you may have guessed from the review that we just did with factoring and solving quadratic equations, we're beginning a really short chapter that reviews quadratic functions. We'll essentially be reminding ourselves of the graphs of quadratic functions and how to graph those, and then doing some application problems. We're starting today with an introduction, so a reminder, identifying the zeros and concavity of a quadratic function, writing quadratic functions if I have the zeros in a point, and doing some application problems. So just as a reminder of quadratic functions, I have a graph over here of a quadratic function. So the shape, as you can see, of a quadratic function is a parabola or a U-shape. It may open up or down. In general, the domain of a quadratic function is all real numbers, and the range, if the graph opens up, will be greater than or equal to the y value of the vertex. If the parabola opens down, it'll be less than or equal to the y value of the vertex. The vertex, remember, is the point where the graph changes direction. So on this graph, I'm going to mark the vertex with a red dot right there, if I can get my finger right there. So the vertex of this parabola is 1, -8, right there where the red dot is. It can be a maximum or a minimum of the graph, depending on which way the graph opens, and it's where the graph changes from increasing to decreasing or vice versa. The axis of symmetry is the vertical line that passes through the vertex, that if we were to fold on that vertical line, the parabola would lie on top of itself. So I'm going to dot in the axis of symmetry here on my graph. It should be vertical there. So the axis of symmetry on my graph would have equation x equals 1. The vertex of my graph would be 1, -8. You can begin reviewing those things. The zeros or roots, they're sometimes called, or x-intercepts, are where y equals 0. So on my graph, the zeros would be at 3 and at -1. I'm trying to draw those little dots, right? So that's where the graph is crossing the y-axis. Not there at 4, but at 3 and at -1. The vertex is always going to be halfway in between the two x-intercepts because the graph is symmetrical. Standard form of the quadratic equation, we saw this when we were factoring, is y equals ax squared plus bx plus c. There's also factored form, which is really useful. So factored form is just if the equation above was factored, so the coefficient a would come out, and then we would have an x minus 2 roots where z1 and z2 are the zeros of the function. So they're where y would be 0. Okay, we're working on this slide on finding the zeros of a quadratic function and the y-intercept, and then sketching the graph. Remember that the zeros are the places where y is 0. The y-intercept is going to be where x is 0. And then once we have those points, we'll sketch the graph. So for the first example here, we'll start with part A, finding the zeros. So I'm going to set y to 0, x squared minus x minus 6. And I can see pretty quickly that I think this will factor nicely. So you know now why we did the factoring review. I'm multiplying to make -6 and adding to make -1. And that means my factors are x minus 3 and x plus 2. Since I have those two factors multiplied equal to 0, I can use the zero product property. They're set equal to 0. I have the product of two terms on this side. That means one of the two factors must be 0. I can continue solving for x. Then I have two kind of smaller equations there to solve. And I'll get x is 3 and x is -2, which gives me, those are the x-intercepts. I could write them as ordered pairs, the ordered pair 3, 0, and the ordered pair -2 and 0. For part B, I'm going to find the y-intercept, which means I'm letting x be 0. I can see pretty quickly that if I let x be 0, I get the y-intercept is -6. So I would have the ordered pair 0 and -6 to graph. And then the last bit of my instructions is that I am to graph it. So I'm going to plot those 3 points. So 3 and 0, -2 and 0, 0 and -6. And then I'm just going to play connect the dots. I'm graphing with my fingers, so it's going to be kind of iffy here. You can probably do better with a pencil on your paper. And I have my parabola. I know it's opening up because the leading coefficient on x squared is positive. It's 1. And so I can just connect the dots and I have a sketch of my parabola. For the second equation, when I start part A, I can actually see pretty quickly in this one that it's not going to factor because the only factors of 5 I have are 5 and 1. And so I know that there's no way I'm going to get -2 in the middle there. So I'm going to need quadratic formula, which we also reviewed yesterday. So I'm going to go straight. I have the equation equal to 0. I'm going to go straight to using quadratic formula. I can give you a quadratic formula program for your calculator if you'd like to use it, or you may program it into your calculator before the quiz. So x equals -b, so 2 plus or minus the square root of -2 squared is 4 minus 4 times a times c all over -2 times a. I can simplify that a bit. So I get 2 plus or minus the square root of 4, and then if I think of that as -4 times 5 times -1, that's positive 20. 4 plus 20 makes 24, all over -4. And then I can use a calculator. I actually have 2 zeros there, so I can use a calculator to get decimal approximations for those. If I get those decimal approximations, 2 plus the square root of 24 divided by -4 turns out to be 1.725, and 2 minus the square root of 24, 0.725. So I have those two as my x-intercepts. My y-intercept, I've kind of run out of room here, so I'm going to kind of draw an arrow. My y-intercept is when x is 0. So if I allow x to be 0, y is -1. Easy one to see. So I have the point 0 and -1. So my two x-intercepts are 1.725. I'm going to have a hard time on my tiny, tiny graph here. It's kind of close to 2-ish, 1.7. And 0.725, oh my, kind of really close right there. And then 0 and -1. I can get 0 and -1 there. This should be -1.72. All right, let's fix that. I have my two y-intercepts, and this graph also opens up, and so do this that way. We can talk about that in class tomorrow if you want, because that's really hard to see on my teeny tiny graph, but we'll do some practice on those. We also want to do application problems of the quadratic form functions, and so here we have somebody diving off a platform. The height above the water is given by a function there. T is time in seconds since the diver left the platform. I need to find and interpret f of 1.5, so I'm just going to substitute 1.5 in place of t. 1.5 equals -4.9 times 1.5 squared plus 8 times 1.5 plus 10. I'm going to use my calculator to evaluate that. So -4.9 times 1.5 squared plus 8 times 1.5 plus 10. I get 10.975. And so my interpretation then, remember my input here is time and my output is height above the water. So I would say at 1.5 seconds, the diver is 10.97 feet. I assume it's meters because it says it's a 10 meter. So meters above the water. After how many seconds did the diver hit the water? So I have to make some interpretation here about hitting the water. So hitting the water means my height is 0. My height above the water is 0. So I need to make that translation and then I can set up my equation. 0 is negative 4.9 t squared plus 8t plus 10. I'm pretty sure that's not going to factor, and I don't want to try to factor with that negative 4.9 anyway. So I'm going to try quadratic formula. So not 0 equals, let's get rid of that. T equals negative 8 plus or minus the square root of 8 squared minus 4 times negative 4.9 times 10 all over 2 times negative 4.9. I'm going to use my calculator to evaluate that. After typing that into my calculator, I get two values. I get that t is either negative 0.829 or 2.462. Since t is time, and this is a question about somebody diving off a diving board, then t equals 2.462 seconds seems like the only reasonable answer there. And then the last thing we're going to talk about is finding formulas, the formula from the zeros and another point on the graph. So we have an equation of a parabola that has x-intercepts, 1 and 3. Those are zeros, also remember, and a y-intercept at 6. So the form that I'm going to use to write my equation, I'm going to start from factored form. So I know that factored form looks like this from the very first slide we did, z1 x minus 0, 2. And so y equals a. I have my two zeros or my two x-intercepts, x minus 1 times x minus 3. And then I know that I have a y-intercept at 6. That means that I have the point 0.06 on the graph. So once I plug in the two zeros, I'm making good headway. I have values for z1 and z2. The only thing I'm not sure about is a. So I can find a by substituting in this 0.6. So I'm going to put in 6 for y. A is what I don't know. 0 for x. And I can solve for a. So I get 6 is a times negative 1 times negative 3 is 3. So a is 2. Now I can write my equation. Y equals a is 2. My x-intercepts are x minus 1 and x minus 3. This is a fine form of the equation. If I wanted it in standard form, I would need to multiply the x minus 1 by the x minus 3. So I'm going to do that just so you can see it, but it is not necessary. Y equals 2 times, I'm foiling these two back together, x squared minus 3x minus 1x makes minus 4x plus 3. Distributing the 2, 2x squared minus 8x plus 6. These are equivalent forms of the equation, just two different forms. And so factored form is fine if you have the x-intercepts, or if the question asks you to write it in standard form, you see how you can translate. Okay, see you tomorrow.